All right, so for an exponential function, it means that your variable is the exponent. So you have something to the x the power. And that something is called a base. So the base number to the x power. Is that done? So your variable is now the exponent. You would have something to the x. What else was I going to say about that? Oh, there is a horizontal asymptote, not vertical. So exponential has the horizontal asymptote, not vertical. The graphs are very simple because they only go one direction. I call them a swoop. They're actually my favorite one. This is like one of my favorite lessons to teach. It's that's it. Or it goes down. Which brings me to the next thing I was going to say. If you have a to the x power, and a could be any number, so 2 to the x, 7 to the x, 5 to the x, that is called exponential growth. It's getting bigger. Have you ever heard such and such grows exponentially? When people say that, what they mean is grows really, really, really fast, because that's what an exponential graph does. Goes whoop. All right, so if you have, instead of a to the x, a to the negative x, which could also be written 1 over a to the x. It could be a fraction, and we're going to get into those negatives in a minute. I'm going to talk about that. Negative just flips it, though, is all that is. That is called exponential decay. Have most of you taken chemistry? Do you talk about like how an element decays and breaks down over time? Like that's usually where that shows up in science is you'll have decay of an element. Like, don't you do that? Like what elements do you do that with? I don't know. It's been forever since I did chemistry. But you know what I'm talking about. Anyway, growth and decay. Yeah, there's a lot of overlap with like math and science. So we're going to state the transformations. This is like up, down, left, right, stretch, shrink. The base number does not cause a transformation. It's just there. So the 5, the 3, the 1/7, those don't do anything. They're just the base number. So for letter A, there's 2 things. What are they? How did it shift? Right 3, good. Left and right is kind of backwards. And then up 8, good. Again, this should go pretty quick if we're all paying attention. All right, there's 2 transformations for letter B as well. What's one of them? Good. The negative is inside, so reflect y-axis. If the negative is out front, it's reflect x-axis. Very nice, whoever said that back there. That's like one of the most commonly missed things, and I totally get it because one is one way and one is the other way. It's hard to remember, but good, y-axis. All right, and then the -4 is down 4. This one has 3 things. What is one of them? Good, the negative's out front, so that's reflect x-axis. I'm not going to go there. Just no, we're going to leave that. The negative is reflect over x. What's something else? Which kind of stretch? Vertical, because the 4 is outside. Good. Vertical stretch by 4. So you stretched it taller. It's going to be 4 times as tall as it was. And then what's the +9 do? Yep, left 9. Left and right are kind of backwards. You could argue that there's also a reflection over the y-axis because there's a 1/7 instead of a 7, but I feel like that's kind of a trick question and I'm not going to go there. Do you get what I'm saying? Like, I'm not going to try and trick you like, oh, 7. If there's a reflection, I'm going to put a negative in it. All right. Now, I have you writing out some of your perfect squares and perfect cubes because you kind of just need to know these. Like, you have to have these in your back pocket to do things with exponents. So the first 12 perfect squares, 1, 4, could you keep it going? 9, good, okay, 16. How about we all write them out and make sure we all get the same thing? I'm not going to just say them all aloud and, put you all to sleep, but you kind of have to know those. And if you know some beyond that, that's great too. I think knowing some of the special ones is important. Like 20 squared would be what? Yeah, 400. Do you know 25 squared? That's 625. Like some of those ones are good to know, but if you know through 12, I'm happy. All right. The first 5 perfect cubes. So 1, 8, 2 cubed is 8. What's 3 cubed? It's 27. 64. Now you have to be careful because that's on both lists. Square root of 64 is 8. Cube root of 64 is 4. And then 5 cubed is 125. And if you know above that, that's cool. I think as long as you at least know to there, you're good. All right. Now this is going to be a review of algebra 2. I'm going to see what you remember here. 3 squared is 9, but do you see that negative? All the negative, and you got to come with me on this because negatives are the most commonly missed thing, but it's really not that hard. All you do is flip it. So instead of 9, it's 1/9. That's literally all the negative does. It doesn't make your answer negative. It just means flip it over. So for this one, 4 cubed is 64, but your answer is going to be 1/64. That is all it does. So please don't overthink it. All right. This one would be 1/49. Okay. Now, this looks scary, but it's actually easier because the negative flips this. So instead of a 1/5, it's actually just 5 cubed, which is 125. So when you have a fraction and then the negative, it's actually better because the negative sort of fixes it. So what do you think for this one? 81. So do not be scared of the negatives. It just means flip it over. Now, right after negatives, fractions are the next scariest things. Let's talk about some fractions. The fractions are the roots or the radicals. A 1/2 is a square root. A 1/3 is a cube root. So when you see this, all that means is square root of 36. So that is 6. How about 49 to the 1/2? That's 7. Follow-up question. How about 16 to the 1/2? 4, good. Or 100 to the 1/2? 10, good. Okay. This one's a cube root. So cube root of 8 is 2. The only difference between these two questions is this has a 2 in it, whereas this has a 1. Do you see that? So this 3 means it's a cube root. You're going to do cube root of 8 and then square it. So it means this, cube root of 8, same as we just did on this one, but then that 2 means that you square it. That's all. So what is that answer going to be? 4. 2 squared is 4. Is all. I get that it looks scary, though. What you have to remember is that these look scary, but they're not actually that hard. Now, this one is a 4th root. What we're doing is looking for a number to the 4th power would give you 16, and that would be 2. I usually like for you to know 2 a little bit further. 2 to the 4th is 16. Do you remember what 2 to the 5th is? Because we did talk about that. It is 32. So 32 to the 1/5 would also equal 2. Where we talked about that was, do you remember the Pascal's triangle thing and the binomial theorem? And I was like, it would be good if you knew 2 to some higher powers because you use them. So 2 to the 4th is 16, 2 to the 5th is 32. All right. We're going to fill in this table for -2 to the x power. And I'm going to start with the 0, 1, 2, 3. We'll come back to the negatives because those are going to flip. So can you stick with me instead of working ahead? We're all going to stay together as a group. Use brain, then speak, okay? What is any number in the world to the 0 power? It is 1. Any number in the world to the 0 power gives you 1. Okay? Now, if you plug in 1 for this, -2 to the 1st is just -2. If you plug in 2, -2 squared is good, +4. -2 cubed, good, perfect. You all came with me on that. Now, when we go to do the other side, you're just going to take these numbers and flip them. That's it. So instead of for the 1, it was -2. For the -1, it's -1/2. And then take this one and flip it. So it would be, well, good, you're coming with me on this. And then you would take this one and flip it. So -1/8. Now we're going to stop and think for a second. What do you notice is happening with these values that we're getting? Good. Negative, positive, negative, positive, negative, positive. Look at me. If you needed to graph this, you would have a negative, a positive, a negative, a positive. Your graph would look like this. Do you see what I'm saying? It's not going to work. It doesn't work. You cannot have a negative base number. No negative base. Here's what's going to happen. I'm a fortune teller. Are you ready? I know the future. 3 classes from now, when we're going over graphing logarithmic functions, and I say, hey guys, there can't be a negative base. Someone's going to raise their hand and go, why? Why? Why can't there be a negative base? Because the numbers do what? They flip-flop. They alternate. It's just not going to work. So please try to remember that so I don't have to explain it over and over and over and over and over again, because I just explained it, and that's the reason why. If you don't want to remember that, that's fine. You just can't have a negative base. You just trust me, all right? Now, when you go to graph these, I love this. This is like one of my favorite things because the graphs are super easy. We're going to fill in the automatic stuff first, all right? Put your automatic answers in there. A swoop goes left and right forever. So what's your domain? All real. Like everything, that's the answer. On a quiz or test, that's the answer. You will get that one right. Then you're going to do the asymptote. There is no vertical asymptote, like by definition. Now the horizontal one, it's usually at 0 unless you shifted up or down. So did this graph move up or down? That's why we practiced it on the other page. Yes, it went down 4. So it's y equals -4, and then you can dot that in. And you can dot it the whole way across. Remember how I talked about doing the horizontal ones just on the edges? Here, you can dot it the whole way across because these graphs are very basic. It's just a swoop, so it's not really going to matter so much. And then we're going to get a table. I would like at least 3 points. You can do more, but at least 3. Now, you want to start where the new center is. For example, please come with me on this. If it went right 7, plug in 7. If it went left 12, plug in -12. Do you get what I'm saying? Okay, so did this one move left or right? It went left 1, so we should probably plug in -1. Go to wherever the center is. And then you would want to pick some numbers next to -1. So like, what else would be good? 0 would be good. Now, I'm going to talk about that because sometimes you do want to go the negative direction. We don't in this case, but thank you for saying that because I'm going to bring that up actually in the next problem. So hold on to that. Here we're going to go to the right though. So -1, 0, and then 1 would be good. So let's plug them in, see what we get. If you plug in -1, -1 plus 1, 0, anything to the 0 power is 1 -4, -3. Now let's plug in 0. 0 plus 1. 1. 2 to the 1 is 2 -4, -2. Now let's do 1. 1 plus 1. Everyone in Algebra 2 always freaks out about what they have to do with the calculator without a calculator. Oh, we don't get a calculator. Like 1 plus 1 is 2. That's what we're doing. 2 squared is 4 -4, 0. Like the math you do is very basic, and we keep the numbers small so that you can do it without a calculator. So graph those, and you should get a swoop-de-doo. All right. You're okay. The graph. And then you will just use that graph to answer the rest of the questions. You will have no brackets in this unit at all. The bracket parenthesis issue, they are all parentheses. Why? Why would we want to Yeah, you don't have to worry about it because it's an asymptote, all right? So when you do range, sweep downwards to upwards, it would be where to where? Yep, -4 to infinity. Just don't put any brackets. You don't even have to worry about it. There are no brackets. All right, how about your x-intercept? 1, 0. See, again, it feels like we're doing a lot, but this should go pretty quick because it's not that hard. All right, y-intercepts, just look at your graph, 0, -2, or look at your table that we made. Now you will either increase or decrease. One of these is going to say none because the graph doesn't turn around. What is this one doing? Yeah, increasing. And your domain is all reals. Isn't that great? You don't even have to worry about it. Like these are, I love these graphs. I think they're the easiest ones because there's just so nothing to them. All right, end behavior. It's been a minute since you've had to write this out, so refamiliarize yourself. Limit x goes to negative infinity of the function. Limit x goes to positive infinity of the function. One side will go towards the asymptote. One side will either go up or down. So where is the left side going? The asymptote, which is -4. I knew what you meant by down. Yeah. And then the right side goes infinity. So one side will be the asymptote. The other side is like, peace, I'm out of here. And it like goes forever. All right, we'll do this one and then we'll do our halfway break. What is one of your automatic answers? Fill in the automatic stuff first. Asymptotes. Vertical is none. Horizontal is y equals however it's shifted up or down. 3, good. And domain is all reals. Those are your 3 automatic things. You just fill them in. It's like ka-ching, ka-ching, points, points, points. All right, now we're going to make our table, and you want to go to where the new center is. So again, like if it went right 9, plug in 9. Like, you want to go to where the new center is. So what's the first number we would plug in? 2, good. Now you want some numbers near 2. I don't want 3, 4, 5. We want to go the opposite direction in this one. And why? Why would I go the other way? Well, not the negative. It's because it's a fraction. We want to flip it because I don't want to graph fractions. Okay. So we're going to go the other way. I'm going to do 2, 1, 0. And we'll plug them in and see what we get. So if you plug in 2, 2 minus 2, 0. Anything on God's green earth to the 0 power? 1. But it is -1 plus 3 is 2. All right, now there's going to, heads up, there's going to be a negative. No panicking, okay? 1 minus 2. -1. But what that does is it flips this. So instead of 1/3, 3. But it's actually -3 plus 3 is 0. I know, see, negatives bother everybody, but remember, it just flips it. All right, 0 minus 2 is -2, but it flips it. So it's really 3 to the 2. So 3 squared. 9. Did you come with me? 9? 3 squared is 9? Okay, good. Head's nodding. Only it's -9 plus 3 is -6. You are going to know if something gets plotted wrong because you won't get a swoop. And this one is like rather stretched out. That's because the base number was 3. If you want to think of it as 3 instead of 1/3, your base number was 3. If your base number was like 10 or something, it would be really, really stretched out. Like the higher that base number is, the more stretched out it gets. That's why I usually keep it to 2 or 3, sometimes a 4, but I really can't go above that because the numbers start to get ridiculous. Remember like the pennies? You have to keep these numbers really, really, really small because it gets outrageous very quickly. And then you're going to just use that picture to answer the rest of this. My hope is this is the quote unquote easy part. All right. What's your range? Sweep down to up. Good. Perfect. No brackets. All right. Your x-intercept. You can look at the graph or look at the table. It's 1, 0. Good. 0, -6. Reading left to right. Are we increasing or decreasing? It is increasing. Left to right. Do you see how it's going up? That bothers you way more than me. If you are awake and talking to me, I'm happy. But does everyone see how this is going up? Okay. And then your end behavior. So write out your limits, -infinity, positive infinity. And one's going to go to the asymptote, which is 3. The other one's going to be like, peace, I'm out of here. It's either going to go up or down. So where does your left end go? Negative infinity. And then the right end goes to 3. It will not ever touch 3. It is behavior. All right. Compound interest. I'm about ready to write a formula up here, and here's what's going to happen. Again, I've got a crystal ball. I'm going to write this up here, and you're all going to freak out. And then I'm going to explain what all the letters mean, and everyone's going to calm down. Cool? All right. It is A equals P parenthesis, and that's how I remember that, P parenthesis, 1 plus R over N to the nth power, NT. It's 1 plus R over N to the nth power. So now I'm going to explain to you what all those letters mean. All right. So A is the amount that you end up with. In other words, that's your answer. A is the answer. A is what you get. P is the principal. That's what you start with. So if you're going to put money in the bank, P is the amount of money you have that you're putting in the bank. R is the interest rate. What do you think T is? Time. And the letter I didn't mention yet is N. N is the number of times that you compound the interest. So number of times it gets compounded. And what I mean by that is it's the number of times that you take the interest and add it onto the total. So if you're trying to make money, the more times you compound, the better, because you take your interest and roll it over into your total, and then you're taking a percentage of a larger number. Is this making sense to you? Okay. So the more times you compound, the better, as long as you're trying to make money. If you have a loan that you're paying back, you don't want it to compound as many times. Do you get what I'm saying? Like you owe money. So let's talk about what the different numbers for N can be. Annually means N is 1. You compound 1 time per year. Semi-annually means 2, twice per year. Did you learn some of this in your economics? Quarterly, what do you think that means? Is 4, I ran out of space. The other one, I wish I could have put that underneath there. It's going to bother me that it's off to the side. Monthly would mean 12. Daily, I guess, would be 365. I've never seen that one, though. So those are the ones that you need to know. But this is your recipe. You're going to be given all your ingredients, and all you do is take the ingredients and put them into the recipe and then tap, tap, tap on the calculator. For right now, I'm going to have you just watch me type in the calculator. When you go to do your classwork, you'll get to practice it, okay? So number 8, find the amount present in an account with principal of 700, 3.5% interest rate, compounded quarterly for 5 years. Those are all your ingredients. We're just going to put them in. What is P? 700. Parenthesis. 1 plus, what's R? Good. Now, if you put 3.5, you're going to catch this because your answer will not make any sense. You will get like $1 billion. All right. You have to move the decimal point. This would be 3%, but it was 3.5, so you just stick a 5 in it. 0.035. You scooch the decimal twice. Right. Over N, what is N? Good. 4. You're at the next part. You're ahead of me because I know where you're at here. And it's to the power N times T. N is 4. We just said that. And T is 5. I wrote 4 times 5. If you put 20, fine. Totally cool. We're going to slap a $ cash money in front of our answer. And all I want you guys to do is watch while I type this and make sure I don't type anything wrong. When I'm typing, that's what your job is. Watch and make sure I don't type anything wrong. Oh, actually, before I type this, What's a number that would make sense for our answer? If we started with $700, our answer should be like 800 or 900. Something a little bit more than 700, but not like 5 billion. You get what I'm saying? Because if your answer is wrong, like if you mistype it, I want you to understand that your answer is not right. All right. So think about what a logical answer would be. There, is that a logical answer? Good. $833.24. So something bigger than 700, but not like a million. Yes, for dollars, we do 2 decimal points. We're going to have a big old conversation about how rounding goes in AP calculus in another unit, but for right now, money means 2 decimal points. All right, so let's just try it again. What is the principle for this one? I just want you to read. Just find all your money. Okay, 1,000. You have $1,000 and nothing better to do with it than stick it in an account. All right, parenthesis, 1 plus, and leave it there for 3 years. All right, what's our interest rate? 10%, so that's 0.10. Go ahead and set the desk down. All right, over what? What's our N number? It says semi-annually, so what's that mean? 2, good. And then it's to the power nt. So 2 times time, which is 3. Or you could just go ahead and put 6. That's fine. Okay. Again, when I'm typing this, your job is to watch and make sure it gets typed correctly. What's an example of a number that would make sense as an answer? Yeah, like bigger than 1,000, but not billions and billions of dollars. I don't know that it's quite 2,000. I think it might be less than that. Oh, how'd you do that? That was crazy. $1,340, and we'll round up to 10 cents. You need a lottery ticket. That was crazy. Everyone that wasn't paying attention, did you hear that? Yeah, I said, here, give a guess, and that's the number she said. That was crazy. All right. So what happens if your interest is compounded continuously? It means that we want n to go to infinity, meaning you're rolling over the interest literally constantly. So what I'm going to do is change a bunch of the numbers in this formula to ones for us to look at this in the calculator. I'm going to make the principal 1, so I'm not going to write that. I'm going to make the interest rate 1. And I'm going to make the time 1. So I made all the other variables a 1 just for the sake of us looking at this. But do you understand why I'm doing n to infinity? Continuously. Okay, just making sure, is everyone listening to me? That means forever and ever and ever. So here's what we're going to do. And I need for you to watch. I'm going to type this in the calculator. I need to use an X instead of an N, though, to make this work. So just so you understand. Do you see how I typed it, but with an X? Yeah. Okay. Because it seems like we're a little bit unfocused here. I'm going to go ahead and make a table. And I'm going to keep this going, but I want to go out to infinity. So counting 1, 2, 3, 4, 5 is not good enough. Let's put some bigger numbers. Here's 100. Here's 1,000. Here's, I don't know if that's 10 million. Do you see how far I'm making it go? Now, do you see how it's kind of leveling off at a certain place there? I need for you guys to get this. Like some of you just are staring at the wall while I'm up here explaining. Like you're going to not understand what's going on later. Do you see how it's kind of leveling off at this number? 2.718, blah, 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 blah. All right, that's where that's leveling off. That's where the asymptote is. It's 2.718 dot, dot, dot. I usually just, if you know the first 3 decimal points, I'm usually happy. This is a special number that is called E. It is the number E. Can you set that desk down? If you're like, what do you mean a number is a letter? You've done this before. What is a very famous number? The pi, 3.1415 is pi, okay? Same thing, except it's E. You need to understand that E is a number and it's 2.7-ish, cool? And this is where it comes from, because I know 3 classes from now, where did that 2.7 come from? This, compounding continuously. So here's your formula for your compounded interest. No one has any problem remembering that formula because it spells PERT. A equals PERT. So these are the exact same two problems that we literally just did, except instead of compounding semi-annually or quarterly or whatever, do you see how it says continuously? That means PERT. If it says continuously, that's PERT. So for this one, it's 700. That's your principal. E to the power R times T. So our interest rate for this one is 0.035 and time was 5 years. Again, I didn't change anything else about the problem. So for the other answer, we got $833 and some change. This one's going to be really, really close to that, except slightly more or slightly less. It's going to be really close to this, but what do you think? Very slightly more because we're compounding all of the time. So when I'm typing this in, your job is to do what? Watch and make sure I don't type anything wrong. Because when you get to your classwork, you guys are going to be typing this. Hold on, I need to get rid of everything that was in here before. Clear all this out. Go away. All right, so 700 E, you can just type E. The calculator knows what E is. And it's to the power 0.035. And then what was time? 5? $833.87. The reason it wasn't dramatically higher is because the interest rate was only 3.5%. It wasn't a very dramatic interest rate. This one's going to be a little bit more because what was our interest rate for this one? 10%. You're going to get a little bit more of a dramatic answer. So it's going to be really close to this 1340, but slightly higher. All right, so we're looking for an answer slightly higher than 1340. So our principal was 1,000. E to the power what? 0.10, that's our rate, times 3. So I'm looking for an answer around 1340, but slightly more. You want to think about what your answer is going to be because it should make sense. What was it, 3? There you go. 1349 and 86 cents. We'll round up to 86. So you memorize the recipe and you plug in your ingredients. That's it. Recipe, ingredients. Calculator does the rest. About how much is E? 2.7. As long as you know it's a number, I'm happy. All right. And then these are your graphs again. This should go quick and easy. Here's the only difference between these and the other ones that we did. And you'll still have 20 minutes of time to do your classwork. You will all get it done. Okay. Here's the only difference. Instead of when you do your table getting 3 points, you're only going to get 1. Because there's only 1 that you can do without a calculator. Unless you can do 2.718 squared and 2.718 cubed without a calculator. Anybody? No. Okay. There's only 1 number you can do. What is any number to the 0 power? 1. So E to the 0 power is 1. So it's the only one you can do. Other than that, same thing we did. What are the automatic things? Jermaine? All real numbers. Do the automatics first. Vertical is none, which is a great answer. Horizontal. Why is it 0? Yeah, it doesn't go up or down. Perfect. Everybody, that's exactly what I wanted to happen. Y'all listen, paid attention, see how fast that was. All right, let's make our table. There's only 1 number you can plug in, and it's not 0. 5. Do you see how it went right? 5? Plug in 5. You want to go to where that new center shifted to. 5 minus 5 is 0. E to the 0 is 1 times a half is 1/2. That is the only point you get. So 5/2. Oh, so our asymptote is at 0. I should have dotted that in. 5 1/2. Now here is where I usually get some kickback, and I understand why that happens. So I'm going to stand up and give you a pep talk. Miss Cole, all we have is an invisible line and 1 point. What on earth are we supposed to do? I get it. There's only 2 things that can happen. The graph either goes up or down. Do you see a negative anywhere in the equation? No, so that means it goes up. So your swoop-de-doo goes like that. You only have 2 choices, up and down. That's it. Now, once you have that picture, should be able to answer the rest of it. Range is going to be what? Yep, 0 to infinity. I'm going to get to that, believe it or not. I'm going to actually tell you the answer, I promise, all right? X-intercept, none. That's a valid answer. There isn't one. Why isn't there one? That's the asymptote. All right, now, do you see how there is a y-intercept? It touches the y-axis. I just don't know what it is exactly. We're just going to plug in 0. Can you watch this before you write it down? Let's just explain, because it's super easy. You actually do nothing. If you were to plug in 0, what is 0 minus 5? -5. So you get, and don't write this, just watch me, 1/2 e to the -5. Whatever that is, do you understand that that's a number? It's 1/2 times 2.7 to the -5. I just don't know what it is without a calculator, but it's some super tiny decimal. That's it, and that's a valid answer. Here, I'll show you. Watch. Humor me. 1/2 e to the power. Any guesses? You want to guess what it is? Really small. Yeah, look at that. 0.003. Do you get it's a number? As long as you know it's a number, I'm happy. All right. Are we increasing or decreasing? Increasing. And then you're going to set up your end behavior. I'm recording this. You can always go whenever you need to. It's recorded. You don't need to feel like you need to, I don't want to make you late to anything. It's recorded. Always watch it. All right, where does your left side go? To the asymptote, which is 0. Will it touch 0? No. And then the right side, infinity. All right, one more, and it should go nice and easy too. You're only going to get 1 point. All right, automatic stuff. Do those first.
Is the increasing always going to be all real?
No.
That's this.
Because what does this equation have in it? Negative. All right, where's your horizontal asymptote? 3. Went up 3. We're going to make a table and get 1 whole point. What can we plug in? There's only one number that'll work. 0. This graph didn't go left or right, so 0 is still your center. You can't negative a 0, it's just 0. E to the, oh, yeah, go ahead. It's how much it moved left or right. So like in this one, do you see how it went right 5? So I plugged in 5. If it went left 6, you would plug in -6, like just wherever it went. So e to the 0 is 1 plus 3 is 4. So 0, 4 right there. And again, I know, and I get kickback on this. And if your feelings are valid, if you're frustrated, that's allowed. All right, I want to validate your feelings, but I'm gonna calm down. It either goes up or it goes down. You see this negative? That's a reflection. So it goes down. It's like this. It reflected over the y-axis. So to answer that question, this time increasing is none and decreasing is everything. So you kind of just look at it and see what you get. I don't have a, it always turns out this way kind of response for that. You kind of just look at it and see what you get. What's the range? 3 to infinity. X-intercept again is none. Great. Y-intercept. Now this time it turned out nice, but again, sometimes you get 0, 5e to the 9th. Do you get what I'm saying? Like it just is whatever it is. So don't discriminate. It's a great answer. And again, one side will go towards the asymptote, the other will be like, peace, I'm out of here. Negative infinity goes to infinity, and then 3.